Hey there, my name's Danielle and I'm an SI leader here at the ARC. I just wanted to cover a problem that was challenging for a lot of students in Dr. Hill's Chemistry 1C class. So here's the problem right here. The value of the equilibrium constant of a reaction decreases with increasing temperature. Is this reaction endo or exothermic? So the first sentence there gives you a lot of key information, enough information to solve this problem. And at first, this problem might seem a little bit daunting because they want you to say if it's endo or exothermic. But there's a really simple trick, a way to solve this problem. And it's known as the Chatelier's principle. Basically, you probably heard of Le Chatelier, but he said that a system that's disturbed will reestablish equilibrium to relieve that stress. So here, the stress would be heat, increasing temperature. So the stress is we're adding heat to the system. And we want to know how that affects the system. So what's the effect of the stress? That's the next question we have to ask. And you could see here it says the value of the equilibrium constant decreases. So the equilibrium constant, as you might know, is K. K EQ. So K is going to decrease. So this is good. Now we have like a good background and basis for this problem. So now we just gotta think it through step by step. First of all, we need to know what K is. I'll write it over here. K is always the concentration of products raised to their stoichiometric coefficient divided by the concentration of the reactants raised to their coefficients. So in this case, we have some unknown reaction. They don't tell us exactly what it is. But we want to know if it's endo or exothermic. So let's write out both. Let's write out endo and exo and see which one makes sense, considering K. An endothermic reaction, as you know, requires heat to run. So I'm going to say some chemical, A, plus heat is in equilibrium with our product, B. That's our endothermic reaction. And then we have an exothermic reaction, which is just the opposite, produces heat. So we have our starting material A again, except this time we're producing two products, one of them being heat. So now let's write out some equilibrium constants for each of these and see what the effect of adding heat is on the equilibrium constant and compare that to the information given in our problem. Then we could solve it without having to think too hard. And then I'll write K for the other reaction. As you can see, they're the same. But now what we need to think about is when we add heat to the system, which one of these Ks is going to change the way we want it to. So here it says that the equilibrium constant will decrease when we add heat. Increasing temperature just means adding heat. So when we add heat, let's start with this first one. When we add heat to this endothermic reaction, we're increasing the number of reactants that we have. So the equilibrium is going to shift to the right toward the products. So we're going to shift to the right. So here we're going to shift to the left when we add heat. So let's think about this for a second. In this first problem, where we have an endothermic reaction and we add heat to it, we're adding a lot of reactants, so then we're going to shift to the right toward our products. So our products, B, is going to increase. And as a result, K is going to increase because they're directly related. And that's not what the problem tells us here. If we increase the heat provided to this reaction of interest, then K should decrease. So it's not endothermic. And now you probably know that it's exothermic, but let me just prove it to you. If we shift to the left, that means we're going to increase the number of reactants that we have in our system. And then K will therefore decrease because they're inversely related, K and concentration of A. So there you have it. The answer to this problem is that this system is exothermic, because when you add heat to an exothermic reaction, it's going to favor the products and K will go down. That's it. Thank you for watching, and I hope you guys have fun with chemistry.